Thanks everyone for joining the session. And today we are going to discuss about what MPLS. Okay, today we are going to discuss about MPLS. What is MPLS? So it's a simple thing, guys, but you must understand the concepts. Okay, I'll tell you one thing. In service provider environment, we have a lot of devices, right? Yes or no? Hello. In service provider environment, we have a lot
Yes,
of
yes,
devices. Okay, a hell lot
yes.
of devices, thousands of devices. So you can say this is a service provider. Okay, this guy is a service provider. As usual, I am taking this color. Okay, so real world we can say Tata is a service provider. Just take it, it's a Tata service provider. And autonomous system number you can consider some 200 something. One second, guys. Right. Yeah, so the autonomous system number of Tata is 200. Yeah, now this is it. Okay, is it clear? So here I have taken only four routers. Okay, so the thing is we are giving internet connection to the services, organizations, and all. Okay, so generally, if any computer is connected here, right? Generally, like this, just understand. It is connected to. Oh, you know, no, 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 no. Let's remove this. Okay, so computer VPCS. Okay, let's take VPCS, two VPCSs, just computer. So how that packet is traveling across the internet. Okay, so you must understand. Okay, see. Suppose here we have only four routers. Just imagine we have 100 routers. Okay. We have a biggest routing table, right? You have routing table in each router, right? It deals with the. So what is routing table? How established a routing table? So there is a we call control plane. Control plane means what? The control plane deals with routing tables and it will establish the routing tables. Okay. The control plane deals with the routing protocols and it will establish the routing tables. Is it clear? So control plane. What do you mean by control plane? I told you number of times. So you open a Google map. If you want to travel from Hyderabad to Bangalore, it will show you all available paths. That available paths, how it will show you? You need to configure your routing protocols and it will show you the available paths. That is what control plane it is. We call control plane. So control plane deals with routing protocols and it will populate the routing tables. In that routing table, you will see all the available paths. Is it clear? Everyone. Hello. Hello. Is it clear? Hello.
Yes, no.
About control plane. Yeah. Now try to
Yes,
understand. We are sending a packets. Some packets to PC2. Just understand. So the source IP address is 192.168.1.1. Just understand. The destination IP address is 1.2. Sorry, not 1.2. Some other network 100.2. It's a internet, right? Okay. Now the PC one sends a packet to this. You can say Hyderabad router. This is and this is Karnool and this is ATP, Anantapur, and this is BLR. Just understand. So I'm giving a name devices. Okay. So if you see right here, oh my goodness. If you see here very closely, okay. Mm, who is trying to join at this time? Yeah. If you see it closely here, right? So we have already configured all the routing protocols. Suppose you can say OSPF. So it is there. Control plane is there. Routing table is already built. Okay. Now I want to send a packet from here. Okay. This is 192.168.1.1. This is 192.168.1.2. Traditional routing, you know, right? Something like 100.2. Okay. So packet I'm sending to PC2. And what is the destination IP here? The destination IP is this, right? So the thing is, the packet will arrive on Hyderabad router, and this router will check in routing table. Do I have a route to reach this destination or not? You know this data plane, right? I'm talking about data plane now. Control plane is building the routing tables after dealing with routing protocols. Now the packet is flowing. This packet processing is called data plane. So once the packet is arrived on Hyderabad router, it will check the routing table. So imagine Here we have only four routers and internet, right? Internet service provider. This is a internet service provider. So they are using more than 1 lakh routers because Tata service provider spread across India. Tata, Airtel, Jio, everything. It's already spread across the India. Okay, thousands of routers they are using. So you can see the routing table is very big, right? You can see a very big routing table. Yes or no? Since you have only few four routers here, you will see small routing table. If you see 1 lakh routers, all one more than 2 lakh routes you will see. You cannot even see with your eyes that routing table. It's very big. Is it clear? Hello. The routing table is very big. So the thing is, so you have a box. In that box, there are a lot of chitties. So you need to pick. You need to search for the chitty called I some red color. You need to pick the red color. There are a lot of papers inside that. Okay, what you need to do? You need to search and open each and every paper and see whether it is a red or not. Right? Generally, what if you have very small papers? See, you have thousand thousand pieces. Out of thousand pieces, you need to search each and every piece. You need to open and see whether it is a red color or not. So in your box, if you have thousand pieces, how much it will take to search for red piece? In your box, you have only 10 pieces. How much time it will take to search for red pieces? Which one is it will take less time?
10.
10, right? So here also for route lookup. So when the packet is received on Hyderabad router, it will check the destination IP address in routing table. Do I have a IP address for this? Do I have a network? This network is there in my net routing table or not? It will check it. So while checking it, right, it's a very biggest service provider. The routing table of this Hyderabad router is very big. So it is out. There are 2 lakhs routers, 2 lakh routes. So within 2 lakhs, I need to check whether it is there or not. This is called route lookup process. Route lookup means it is checking the destination IP in their routing table. This lookup will take a lot of time, right? Yes or no? The lookup, route lookup, the processor will check each and everything, and the lookup will take a lot of time. Yes or no? There is a delay, right?
Correct.
Right? So in service provider especially, that's why they introduce MPLS. Okay, MPLS. MPLS multiple protocol, multiple protocol. What is that, man? Why it is going?
Layers. Layers.
Multi-protocol layers level switching.
Label switching. Yeah, here my mouse was gone actually. That's what I was. So MPLS is called multiple protocol label switching. So the thing is, in traditional networking, the route lookup is happening in routing table. Okay, but now, especially in service providers, to avoid these issues, they develop a technology called MPLS. What it will do, So what you have to do, you need to configure MPLS on all these devices. Now, how the packet will flow, I'll tell you. Once the packet arrives here, right, on Hyderabad router. So before going to data plane explain, let me explain control plane of MPLS. Once you configure MPLS on all these devices, right? Suppose you configure MPLS here. So what it will generate? It will generate a label. So MPLS header, we have a MPLS header. Okay. So in the MPLS header, you have a 32-bit header. It's a 32-bit header. Out of 32-bit, 8 bits. Okay. There are 8 bits. Uh, you can say uh, 8 bits is for and 3 bits is for cost. I will tell you one more. So 8 bits and 3 bits and 20 bits. Okay. So if you see right in MPLS header, total it is a 32 bit and we have experimental bits we have. Okay, 3 bits are experimental bits and there is a 1 bit is there. It will tell you the bottom of stack. Okay, so total 32 bits. Okay, so 8 bit is for TTL. Okay, and 3 bits for, it will tell you, 3 bits for experimental bits. Experimental means for cause and all, for cause purpose they use. And this will tell you bottom of stack. So currently forget about all these three. We'll discuss later. Only discuss about 20 bits. 20 bits means 2 power of 20. You know, right? 2 power of 20 in subnetting, just you know, right? So this many labels you need to use. So there's a huge labeling. Okay. Label. What do you mean by label, man? It's a tag. So in your data center or in your rack, right? You on the cable you will add a label, right? This cable is connected to which interface? You will add a label, right? Same thing, some label. Okay. So remember this thing. This is a MPLS header. So in MPLS header there are 20 bits which are allocated for label generator, labels. Okay. Suppose you just configure MPLS on Hyderabad router, it will generate a label called 10, something just like that. Understand? Okay, simple. It will generate a label 10. So when it will generate label, you need to to generate a label, right? You need to configure a protocols. Configure protocols. What protocols we have to generate label? We have two protocols. One is LDP, another one is RSVP. So most frequently they use LDP, label distribution protocol. Okay. So what we can do, the LDP will generate a labels. So now MPLS you configure, right? Why you configure LDP? So MPLS is just to understand the labels. It's a family. MPLS is a family. So this MPLS traffic should understand, right? We just enable MPLS, and for label generating we use LDP. So what we need to configure here, MPLS as well as LDP. So RSVP, LDP, either anything you configure it, but just understand. So on Hyderabad router, I just configure MPLS as well as LDP. So what will happen immediately? Once you configure LDP, the Hyderabad will generate a label called 10 here, and it will tell you to kernel. Hey kernel router, if you are sending any traffic to me, attach that traffic, attach this label to the traffic and send it to me. Okay, it means where exactly this MPLS will be attached, it is after layer 2 header. After layer 2 header, between layer 2 and layer 3 header. Because if you see layer 3 header directly, it will do route lookup. So we don't want to do any route lookup. We want to do label lookup to speed up the lookup process. To speed up the lookup process. Okay. So this one coming from Hyderabad. Hyderabad label is 10. It means Hyderabad is advertising to label 10 to kernel router saying that, hey, kernel router, if you want to send any traffic to me, attach this label and send it to me. Similarly, here Anantapur is also there, right? It will also send a label. Suppose label 30. What is happening, man? Who is accessing my computer?
Should I tell something? I
No, no,
need
no,
to.
no, not now, not now. I haven't completed. Okay. Let me complete entire process, and we can start discussing the things. Okay. I'm middle of the session. I don't want to interrupt this. Just 2 minutes. Okay. I'll finish it. Okay. So once you configure MPLS, right, LDP, this Hyderabad router will generate a label, 20 bits, anything. So it will generate a label. It will tell to kernel router. Okay. And Anantapur router also will generate a label and tell to kernel router. So what is that? What is happening, man? Okay. So where are we now? Yeah, here. Anantapur router also will generate a label, ATP label, some 20 you can say. Just understand, just random number. Okay. So yeah, this is thing. And kernel router also, it will tell to Hyderabad router. Hey Hyderabad router, if you want to send any label to me, send a label with kernel, KNL, you can say 30 label. Just KNL 30. Okay. Just understand. Okay. Now Anantapur also receives the labels from where? Kurnool as well as Bangalore. They're neighbors. So once you configure LDP, LDP neighbors will be discovered, and the neighbors will announce the labels. So KNL label, it is, what is the KNL label? It was 30, right? 30. And BLR label, it will receive BLR label. You can say 40. Just understand. Okay. So it means Anantapur router receiving a label from KNL 30, Bangalore router receiving a label from label as 40. Now then Anantapur also sending a label, right? What is the label? 20. So here you will see ATP label 20. Just so now once you configure LDP, so labels are exchange each other. Okay. Now what will happen, here? So let's see. Where is a here, right? Packet. When P1 sends a ICMP packet to Hyderabad router, so you know what? Here you need to configure LDP, right? So immediately it will identify a path. What path? LDP path. Okay, it's already established. So LDP neighborship is already established. So if you see, right, LDP neighbors are already established, right? LDP you have configured, everything is established. So it will check the path. It will not go to the routing table path. It will check the LDP table, MPLS table. So we have a routing table, right? Similarly, we have a MPLS you configure, right? MPLS table we have. In that MPLS table, you have all the labels like KNL30 and all. Okay. What will happen? The packet arrives here, and the packet is the destination IP address is what? Simply whatever it is, some Bangalore, the destination 192.168.100.2. Just understand. So what will happen? So it will not check the it will check the destination IP, and it will check the destination IP, and it will try to find a path. So we have a table, right? We have a MPLS table as well as we have a routing table. Okay. So this destination IP address is there in both MPLS table as well as what routing table. In MPLS table, what it is having? It has a path saying that to reach 192.168. What is that? 100.2 attach label KNL30. Okay. Attach label 30 and send to KNL router. Okay. This information is there in MPLS table. We have normal routing table also. So to reach 192.168.100.2, reach KNL router, whatever the next hop it is generally. Okay. So there are two tables. So this same destination, right? This same destination will be present in MPLS table and routing table, but router prefer MPLS table first. Okay. It will check the MPLS forwarding table and see 100.2. To reach 100.2, I need to reach KNL first. So that what it will do? So it will not do route lookup. First it will do what? MPLS lookup, label lookup. It will do label lookup. Labels are very small, right? Label IP addresses are very big. Which table is big? Routing table or MPLS table? Routing table is have 2 lakh routes, but MPLS is not like that. It has very small labels, very small information we have. Okay, so MPLS labels are 2 port 20 only, but routing routes are 2 port 32. It's very big. Okay, so MPLS label table, it will check it forwarding table and find the path to reach kernel. First, you need to go kernel. So what will happen? So before that, it's IP header, right? Before that, it will attach a label, MPLS label. Okay, MPLS label. What it will attach it? It should go to kernel, right? If you want to go to kernel, what label it is attached? Label 30. Okay, it will attach the label 30. So this attaching process we call push operations. Okay, we have MPLS operations. So what happened? The packet arrives on here. Okay, it will refer the MPLS forwarding table and finds that to reach 100.2, we need to attach the label 30 and send to kernel router. It finds this information here. This process is called push operation. Okay, it will attach the label and send to kernel router, right? This attaching the label is called push operation. Now, this packet go to kernel router. Now, kernel router receives this packet 100.2. As usual, the kernel router also having MPLS table. So there it is saying that to send to reach 100.2, attach the label what? ATP label. Attach the label 20 and send to Anantapur. So here what is happening? It is swapping the labels, right? It receives the label with 30. Yes or no? The kernel router receives this information with label 30. Now after doing MPLS forwarding lookup, it finds that We need to send a packet to ATP router with label 20. It means it is replacing with 20. This process is called what? Swap operations. What is that? Swap. Understand, guys? Swap operation. So the label is, so see here, simple. Hyderabad router sending a packet to kernel router with label 30. Now it will find the MPLS table to reach 100.2. What will happen? You must reach to Anantapur router with Anantapur what router, what label it is sending? 20. So send this information with attaching label 20. Now it is going to Anantapur router. Same thing. Anantapur router receives it. It will check the 100.2 should reach via Bangalore router. So to reach Bangalore router, what is the label I need to attach? Bangalore label is 30. So here also what will happen? Swap operation will happen again. Okay. I'm just telling general MPLS stuff, not L3 VPN other stuff. Okay. Now after this, again it will go to Bangalore router. Now Bangalore router receives this label generally. So now to reach 100.2, I need to exit through E1 interface. Now there is no MPLS router right here. Understand? Is there any MPLS router here? This is the last router. So that's why what we call it's a egress. It's a egress router. So in MPLS, remember one thing, the direction is very important. In this direction, egress router is this because it's the last MPLS router and the packet is egressing here. Why it is egress, you know? See, it will check the 100.2. There is no MPLS forwarding table. MPLS forwarding table is there, but this for this to reach 100.2, 100.2 is not there in MPLS forwarding table. It is there in routing table. So finally, it will do what? Routing lookup. So before that, what it will do? It will remove the label. It will remove the label. This operation is called what? Pop. Okay. This operation is called what? Pop operation. Removing the label at the last. So finally, BLR router receives this packet with label 40. However, however, you know, however, there is no route in MPLS forwarding table. So because it's a last router, so it will refer the routing label now. So routing table, it will do normal route lookup and the packet will go to the PC2. It means in core network, the packet processing is happened through labels. It was very quick. It is very quick. It is super expressway. Okay. So here it is popping the label, right? It means it is removing the label. This is called egress router. And whenever push operation happens, right, on the device, the direction, here it is called ingress router. Ingress router. Okay. So direction is very important because the data is traveling from PC1 to PC2. In this direction, Hyderabad is the ingress router, Bangalore is the egress router. Suppose if the data is traveling from PC2 to PC1, what is the ingress router? Bangalore is the ingress and Hyderabad is the egress. So this is how MPLS works. So at the middle of the core network, right? Middle of the core network, both will exchange the labels each other and they will do route lookup, not route lookup, MPLS label lookup and forward the data, their neighbors. So this is simple MPLS operations. Now, if you have any questions, please ask me. Everyone are able to understand? Just asking. Hello, are you able to understand?
Yes.
Is it simple
Yes.
or
Yes. Yes.
hard?
Yes.
Simple, means
Simple only, right?
understandable.
See, yeah, it's
Means
a simple thing, right? So now label is 20 bits, right? So for MPLS header is 32 bits, you know, for 32 bits and 20 bits is for what? Label generating. And I said 3 bits for experimental bits. And S, this is the 1 bit is for S. S means bottom of stack. Okay. Is F is equal to 1, right? It's a lost label. Okay. It means you have only one label on the packet. So in MPLS L3 VPN, you will see two labels. Label on label. Okay. So if S is equal to 1, right? It's a bottom of stack. It means it's a last label. There is no label here. It's a, only one label is attached with it. So if it is S equal to 0, one label. If S equal to 0, right? More labels. More labels means more labels are attached. It means encapsulation. It is encapsulation with label top of that. One more label is there. So this is it represents this. And another 8 bits are for TTL value. You know, right? TTL. Yeah. This is it, guys. Okay. So it's a very simple. And now keep this in mind. Now here there are two things. One is control plane, another one is data plane. Whatever I tell, right, this MPLS operations, it's called data plane. It's called data plane. How the packet is traveling on across the network. It push swap pop operations. This is called data plane. What is control plane? You must configure MPLS as well as what LDP. Okay. So tomorrow we'll continue the lab. If you have interest, we can do that. But tomorrow we can continue if you want, because you might do the communities, right? I don't want to lag it. Okay. Let's learn very carefully and very neat way. Okay. So this is the ingress router. This is the egress router. So whatever the theory I discussed, right? I'm going to write a beautiful document like PDF like this, and I'll share it to you. So how? So I want to create a PDFs, not PPTs. What do you say? PDFs will give you clear information with more information, and you can take a printout and learn it. Guys, I'm telling you, this thing you will not get outside. This is written by my own and the direct point. Okay. Once you learn this, you can learn more extra from internet if you want. Okay. Yeah. So this is about MPLS stuff. MPLS with LDP. Yeah.
So,
Sir, can you explain this one bit in this MPLS header? One S
Yeah.
means S represents one means what is it?
Yeah, yes means bottom of stack ma. It means what?
Bottom
You
stack.
you have
Okay.
7 layers, right? OSI 7 layers. For
Uh-huh.
raw
Yes.
data, you have a Ethernet layer, then IP
Oh,
header layer, right? It is encapsulated too. Here, same thing. Same
acha.
label only. First, for the
Uh-huh.
data, it is encapsulated with one label. If it is only encapsulated with one label, the S will equal to one. It means only one label it is encapsulated. It means it is protected your data with one label. If you
Okay.
see S equal to 0, it has more labels. It means top of that label, you may see one more label also. Okay.
Okay.
It is protected with
Acha.
two labels like that. Understand?
Okay.
That
Okay.
is, yeah, it represents that. Okay. And we have this is the labels, right? This is the labels are generated. These labels are generated, but we have a reserve labels. Reserve labels. Okay. Implicit null. I will discuss tomorrow. I don't want to confuse you that. So we have reserve labels like we have a ports, right? Reserve ports like that in this MPLS, LDP or whatever it is. We have a reserve labels. Tomorrow I will discuss that one by one. See, BGP we have discussed for 6 days, right? 6 or 7 days, right? We have discussed 6 days. One more class is there, features. See, but now you're good at BGP, right? Everything. We have discussed everything in BGP, guys. Maximum. Okay, do all the labs BGP we have discussed. Now you're good, you can crack any interview in BGP. Okay, now MPLS also I want to discuss for 5 to 6 days. Okay, so remaining stuffs are very small. This CCNP training is more focusing on the concepts which are lively used. Okay, which are very used, popularly used in devices. Okay, in networks. So this architecture is only simple, you already know. I will explain it again. So MPLS, I started it. So only MPLS is there. And then during this MPLS, we will cover LDP, RSTP, and all these features. And then security features, tech hacks, and ACLs we have already learned. We'll learn more if you want. Okay. So then next, security, DSCP snooping, dynamic op. So everything will come here. Okay. Radius, tech hacks, everything we will see here. VRS already covered in MPLS. Okay. So BGP will take 7 days, MPLS will take 7 days, 7 to 8 days. Though so 80% of the syllabus is from MPLS BGP only here. Okay. So yeah, in case if you want to learn more, stacking also I want to include here. That is another core concept. Enterprise, I will add it here. Okay. No problem. Okay. So I will teach each and everything, whatever I have mentioned here, but in a precise manner. Okay. Yeah. That's all for today. Thank you.